We do not know where this journey will end. Yet we know this. Human beings are headed into the cosmos.
Niemand hat den Traum von der Eroberung des Weltalls so konsequent verfolgt wie die Vereinigten Staaten von Amerika. Sie versprachen, Menschen auf den Mond zu bringen. Und sie taten es.
Tranquility Base here. The Eagle has landed.
Keine andere Nation hat so viele Raumschiffe ins All geschossen. Keine andere so viele Katastrophen durchlitten.
The President of the United States.
In reaching the moon, we demonstrated what miracles American technology is capable of achieving. And now the time has come to move more deliberately toward making full use of that technology here on Earth.
(1972) geht das Zeitalter der Mondflüge zu Ende. Die Ingenieure und Astronauten der NASA haben einen Menschheitstraum in Erfüllung gehen lassen. Mit Apollo 17 erobern sie zum letzten Mal den Mond.
I was strolling on the moon one day.
Während auf dem Mond die amerikanische Flagge leuchtet, erleben die USA auf der Erde ihre erste Niederlage. Im Vietnamkrieg verlieren nicht nur Millionen Menschen ihr Leben, auch die US-Regierung verliert ihr Gesicht. Der Krieg spaltet die Nation. Amerikas Jugend träumt von Flower Power. Die Supermacht kann dem keine eigenen Visionen entgegensetzen. Da unterbreiten Raumfahrttechniker Präsident Richard Nixon die ersten Vorschläge für ein neues Abenteuer im All. Während sich die USA aus Vietnam zurückziehen müssen, gibt Präsident Nixon der NASA den Weg frei für etwas ganz Neues. Etwas, das nicht wie eine Rakete im All verglüht, sondern wie ein Flugzeug in den Weltraum vorstoßen und danach zur Erde zurückschweben kann. Tausende von Mitarbeitern der amerikanischen Raumfahrtbehörde tüfteln an einem neuen Typ von Raumfahrzeug für bis zu 7 Astronauten und mehr als 20 Tonnen Nutzlast. Die Sowjetunion, der ewige Rivale im All, hat dem nichts Vergleichbares entgegenzusetzen. Ein wiederverwendbarer Raumgleiter. Ein Pendler zwischen Himmel und Erde. So lautet der Plan. Mit dem Space Shuttle beginnt ein neues Kapitel der Raumfahrt. Der Flug ins All soll zur Routine werden und zum kommerziellen Erfolg.
Together, as the Bible says, we can move mountains. Thank you very much.
Der Weltraum. Unendliche Weiten. Wir schreiben das Jahr 2200. Dies sind die Abenteuer des Raumschiffs Enterprise.
Als der Space Shuttle am 18. Juni 1977 auf dem Rücken eines Jumbo-Jets zu seinem ersten Testflug startet, trägt er den Namen Enterprise, so wie das Raumschiff aus der erfolgreichen TV-Serie. Tausende von Fernsehzuschauern konnten die NASA zu dem Namen überreden. Aus Science Fiction wird reale Wissenschaft. Der Shuttle beweist, dass er tatsächlich wie ein Segelflugzeug landen kann. Doch bis zur Feuerprobe vergehen noch 4 Jahre. Am 12. April 1981 ist es soweit. Die Besatzung der Raumfähre Columbia bereitet sich auf den ersten Start eines Shuttles vor. 20 Jahre nachdem der erste Mensch ins All aufgebrochen ist. Der Start hat sich um 2 Tage verzögert. Computerprobleme. Es sollen nicht die letzten gewesen sein.
T-minus 10, 9, 8, 7, 6, 5, 4. We've gone for main engine start. We have main engine start.
Ein Start wie aus dem Bilderbuch. 2 Raketen mit festem Brennstoff und ein riesiger Tank mit flüssigem Treibstoff verleihen dem Koloss den nötigen Schub, um die Anziehungskraft der Erde zu überwinden. Doch einige Experten schauen dem Shuttle mit gemischten Gefühlen hinterher. Sie halten den Einsatz von Feststoffraketen für zu gefährlich. Die NASA setzt trotzdem auf diese Technik, denn sie ist billiger als der weniger riskante Antrieb mit nur flüssigem Treibstoff. Der gelungene Start scheint der NASA recht zu geben. Wie geplant wirft der Shuttle die ausgebrannten Feststoffraketen in 50 Kilometer Höhe ab. Nach weiteren 70 Kilometern klingt der Shuttle den riesigen Tank aus und fliegt mit 28.000 Kilometern pro Stunde um die Erde. Der erste Flug soll vor allem zeigen, dass es geht, dass man Raumschiffe, die durchs All fliegen, auch wieder zur Erde zurückholen kann. Die NASA ist sich ihrer Sache sicher. So sicher, dass sie beim Space Shuttle auf alle Sicherheitseinrichtungen für die Besatzung verzichtet.
Altitude 152,000 feet, range 211 miles.
Out of 56K, looking good.
Diese Bilder gehen um die Welt und mit ihnen die Vision einer Raumfahrt, die zu etwas Selbstverständlichem werden soll. 60 Flüge pro Jahr plant die NASA. Ein Höhenflug, der schon bald durch die astronomischen Kosten gebremst wird. Statt $10 Millionen, wie ursprünglich geplant, wird ein Space-Shuttle-Flug bald bis zu $500 Millionen kosten. Doch 1981 ist die Shuttle-Welt noch in Ordnung.
50 feet. 40, 30, 20, 10, 5, 4, 3, 2, 1, touchdown. Those gears 10 feet. 5, 4, 3, touchdown. Put the ball, skipper. Welcome home, Columbia. Beautiful, beautiful.
Nach 2 Tagen im All, am 14. April 1981, kehrt die Columbia zur Erde zurück. Anfangs wird der Shuttle allein als Wunderwerk der Technik gefeiert. Doch schon bald entwickelt er sich zum Machtinstrument des Kalten Krieges, für das die immensen Kosten keine Rolle spielen.
Space. Nowhere do we so effectively demonstrate our technological leadership and ability to make life better on Earth. We are first, we are the best, and we are so because we're free.
But above all, more than anything else, we got America to stand tall.
In seinen Wahlkampfspots Anfang der 80er Jahre setzt US-Präsident Ronald Reagan ganz auf Stärke. Das militärische Kräftemessen zwischen Ost und West spitzt sich zu. Nach dem Einmarsch der Sowjetunion in Afghanistan rüsten auch die USA immer weiter auf. Ob zur See, zu Lande oder in der Luft. Überall setzt die amerikanische Regierung auf technologische Überlegenheit. Selbst das Weltall wird zum potenziellen Schlachtfeld. Der US-Präsident erklärt den Krieg der Sterne.
To turn their great talents now to the cause of mankind and world peace, to give us the means of rendering these nuclear weapons impotent and obsolete.
Ein Raketenabwehrschild soll die USA und Europa vor einem Überraschungsangriff mit Langstreckenraketen schützen. Raumfähren spielen in diesen Überlegungen eine wichtige Rolle. Sie sollen die Laserkanonen und Radarschirme in Stellung bringen. Die Pläne zum Krieg der Sterne werden zwar nie realisiert, dennoch dient der Space Shuttle den Militärs. Fast 1/3 aller Missionen haben einen militärischen Hintergrund. Welchen? Davon erfährt die Öffentlichkeit nichts. Für Schlagzeilen sorgen allein die wunderschönen Bilder der Erde, die die Astronauten an Bord der Shuttle-Missionen aufnehmen. Live können die Fernsehzuschauer das Aussetzen von Satelliten miterleben. Oder den ersten echten Raumspaziergang. Am 7. Februar 1984 schwebt ein Astronaut zum ersten Mal ohne Sicherungsleine durchs All. 264 Kilometer über Hawaii. Dass die Astronauten bei fast jedem der ersten 25 Flüge mit technischen Problemen zu kämpfen haben, verheimlicht die NASA. Nichts soll die gute Stimmung trüben, als 1985 insgesamt 9-mal ein Shuttle startet. Rekord. Was damals niemand ahnt, nie wieder werden so viele Menschen in so kurzer Zeit ins All transportiert.
America has always been greatest when we dared to be great.
»28. Januar 1986. Der Tag, der alles verändern wird. Die 25. Mission kurz vor dem Start. Es ist bitterkalt. Ein Techniker warnt vor möglichen Problemen mit Dichtungsringen aus Gummi bei diesen Temperaturen. Vergeblich. Die Lehrerin Christa McAuliffe macht sich auf den Weg zur Startrampe. Unter 11.000 Lehrern wurde sie ausgewählt. Ein Teacher in Space, um amerikanische Schulkinder für die Raumfahrt zu begeistern. Sie werden nie erfahren, was McAuliffe zu erzählen hat.
We have main engine start. 4, 3, 2, 1 and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Now control. Roger, roll, Challenger.
Engines throttling up, 3 engines now at 104%.
Challenger, go with throttle up. Roger, go with throttle up.
73 Sekunden nach dem Start explodiert die Raumfähre Challenger.
Negative contact, lost downlink. Okay, all operators, watch your data carefully.
Alle 7 Besatzungsmitglieder sterben. Und mit ihnen der Traum von der Raumfahrt als Routineunternehmen.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.
Flight photo. Go ahead. RSO reports vehicle exploded.
Nach der Katastrophe die Spurensicherung. Neben den Bruchstücken der Challenger werden auch einige der Astronauten vom Meeresgrund geborgen. Gefangen in ihren Sitzen. Denn Schleudersitze oder eine im Notfall absprengbare Kabine gab es nicht. Aus Kostengründen. Akribisch werden Tausende von Trümmerteilen zusammengefügt. Niemand weiß, ob jemals wieder ein Space Shuttle an den Start gehen darf. Die führende Raumfahrtnation steht unter Schock. Das Puzzle soll helfen, die Ursache des Desasters zu finden. Aufnahmen der Startphase führen auf die richtige Fährte. Grauer Rauch tritt aus einer der seitlichen Feststoffraketen aus. Dichte und Farbe deuten darauf hin, dass Gummi verbrennt. Ein Problem, auf das ein Techniker kurz vor dem Start hingewiesen hat. Sekunden später nimmt das Schicksal seinen Lauf. Flammen springen auf den Tank mit dem Flüssigtreibstoff über. Die anfälligen Gummidichtungen an den Raketen und die Tatsache, dass die NASA Warnungen offenbar systematisch ignoriert, werfen das Shuttle-Programm um Jahre zurück. Doch plötzlich wendet sich das Blatt. Die russische Buran macht von sich reden. Jahrelang haben Moskaus Forscher an ihrer Version eines Raumgleiters gearbeitet. Die große Ähnlichkeit zum Space Shuttle lässt Spionage vermuten. Schlimmer noch, die Buran soll schon bald ins All, während die Amerikaner noch nach den Ursachen für die Challenger-Katastrophe forschen. Der US-Kongress fordert, angesichts der russischen Konkurrenz, die rasche Wiederaufnahme des Shuttle-Betriebs. Der Kalte Krieg wischt alle Sicherheitsbedenken beiseite. Am 29. September 1988 geht die Discovery an den Start. 6 Wochen vor dem ersten und einzigen Flug der Buran. Eine der letzten Shuttle-Missionen im Zeichen des Ost-West-Konflikts. Denn auf der Erde ändern sich die Verhältnisse. Eine Wende auch für den Space Shuttle.
This is a promising moment. Instead of building weapons in space, Russian scientists will help us to build the International Space Station.
Anfang der 90er Jahre darf der Space Shuttle endlich das, wofür die Ingenieure ihn konzipiert haben. Allein der Wissenschaft dienen. Die Astronauten bringen das riesige Weltraumteleskop Hubble ins All. Mehr noch, nachdem sich herausstellt, dass es defekt ist, brechen sie auf, um es zu reparieren. Ohne Raumfähre wäre die Reparatur nicht möglich. Die Operation am Teleskop gelingt. Atemberaubende Bilder aus den Tiefen des Universums sind der Lohn. Die 4 im Einsatz befindlichen Space Shuttle ermöglichen auch den Startschuss für ein weiteres Weltraumprojekt, die internationale Raumstation ISS. Ab November 1999 entsteht 370 Kilometer über der Erde eine neue Heimat für mehr als 6 Astronauten aus Nordamerika, Europa und Russland. Ein Arbeitsplatz für Experimente in der Schwerelosigkeit. Eine Produktionsstätte für neue Werkstoffe soll es werden. Doch der Bau der ISS dauert länger und ist teurer als gedacht. In Friedenszeiten, ohne den Wettlauf gegen die längst untergegangene Sowjetunion, sind die Kassen der NASA nicht mehr so prall gefüllt. Ironie der Geschichte. Ohne die veralteten, aber zuverlässigen russischen Raketen wären die Astronauten an Bord der Raumstation längst verhungert. Sie können nur noch die notwendigsten Wartungsarbeiten durchführen. Die Amerikaner müssen ihre Shuttleflüge unterbrechen. Für die NASA beginnt ein weiteres dunkles Kapitel ihrer Geschichte.
It is time for America to take the next steps.
Anfang des 21. Jahrhunderts durchzieht die Welt eine Spur des Terrors. Die USA erklären den sogenannten Schurkenstaaten den Krieg. Am 16. Januar 2003 bricht die Raumfähre Columbia zur 113. Mission eines Space Shuttle auf. Mit 5 Männern und 2 Frauen an Bord. Neben mehr als 100 Experimenten nehmen sie sich Zeit für eine Schweigeminute zum Gedenken an die Opfer der Challenger-Katastrophe vor genau 17 Jahren. 4 Tage später bricht der Funkkontakt zur Columbia abrupt ab.
Roger, roll, Endeavour. And Columbia, Houston, we see you. Roger,
Die Flugkontrolleure ahnen nicht, dass in diesem Moment die Astronauten in 60 Kilometern Höhe verglühen. Der Shuttle zerbricht beim Wiedereintritt in die Atmosphäre. Das Unglück kommt derart überraschend, dass viele zunächst an einen Terroranschlag glauben. Das erste Attentat im All? Doch rasch wird klar, ebenso wie die Challenger ist die Columbia ein Opfer von technischen Pannen und unglaublicher Ignoranz. Bereits zum Zeitpunkt der Trauerfeier versucht eine Untersuchungskommission, die Gründe für das Desaster aufzuspüren. Was sie herausfindet, wirft kein gutes Licht auf die Verantwortlichen für das amerikanische Raumfahrtprogramm. Bereits beim Start der Columbia prallt ein Stück Isolierung des Tanks gegen den linken Flügel des Raumschiffs. Der Schaden wird sogar bemerkt. Doch weitere Untersuchungen lehnt die NASA ab, da keine gravierenden Folgen zu befürchten seien. Ein folgenschwerer Irrtum. Denn Tests nach der Katastrophe zeigen, dass selbst kleinste Stücke Isoliermaterial große Löcher verursachen können. Die Untersuchungskommission fordert stabilere Konstruktionen, um ähnliche Unfälle in Zukunft zu vermeiden. Die Astronauten sollen kleinere Schäden sogar im All reparieren können. Sommer 2005. 2,5 Jahre nach der Katastrophe ist es wieder soweit. Keine Raumfähre ist jemals so gründlich auf einen Start vorbereitet worden wie die Discovery. Jene Raumfähre, mit der sich die NASA bereits nach dem Challenger-Crash wieder ins All wagte.
Good evening and welcome to the Return to Flight Task Group's post-final public meeting news conference. We apologize for getting a late start. It's been a very busy day for the task group, very busy weekend for the task group. To my immediate left is task group's co-chairman, Richard Covey. To his left is the task group's operations panel lead, Mr. Joe Casapoli. And to his left is the task group's operations panel lead, Colonel Jim Adamson. Dr. Dan Crippen, as most of you know, had another meeting and actually had to leave the public meeting a little early, so he's not with us this evening. We'll have opening statements from each, I believe, of our panel members, and then we'll take questions. One administrative note at the end of the briefing. We will roll some B-roll from today's public meeting.
Thank you, Dave. And just clarification, he introduced both these guys as ops panel leads, and it's really a technical panel for Joe. I think everybody knew that.
Okay, then I don't have to answer any questions.
Let's see, on behalf of General Stafford, who was unable to participate in our meetings today, except for briefly by telecon earlier today, I'd like to thank you for the opportunity to come and talk to you one more time. As we discussed earlier today, and we have over time, I'd like to reiterate that the Return to Flight Task Group was chartered by a NASA administrator to perform an independent assessment of the agency's actions to implement the recommendations of the CAVE, specifically the 15 that were identified as return to flight. Very specific charter. And we also are afforded the opportunity to make observations within our charter, make observations as they apply to operational readiness and safety. We are to report to the administrator through interim and a final report. And so with our activities today, we're getting closer to that final report. Task Group is chartered as an advisory body only under the Federal Advisory Committee Act. So we provide advice to the administrator. And the administrator, along with the rest of NASA, will take that advice and use it in the context of everything else that they are doing and the other information available to determine the readiness of flight for STS-114. We will not make a specific determination on whether it's time to return to flight. Okay, that wasn't our charter. We're supposed to assess those 15 recommendations, which are only part of the actions that NASA has taken to get ready to fly. Over the past 2 years, the task group has conducted extensive fact-finding. When we started this, the group anticipated a 6 to 9 month time period. That was what most of us signed up for, so the fact that we're on our 24th month now says that clearly the commitment of time by the task group members has been more than they had anticipated. But during that time period, we have visited facilities, we've reviewed documentation, we've interviewed individuals, received many briefings from NASA. We've attended NASA simulations, meetings, their reviews, And as I've said earlier, we periodically have reported our findings to NASA and the public, both in a written form and then through our public meetings and ability to conduct press conferences. Today, the task group completed an assessment, completed the assessment of the CABE's 15 return flight recommendations. In addition, previously we had completed our assessment of Space Shuttle Program Action 3, having to do with using the space station for safe haven and a potential launch on need rescue. During this time and in preparing to get ready for flight and addressing the CABE recommendations, the efforts undertaken by the agency have been extraordinary and outstanding. And I know from our reports and from the things you've heard from NASA themselves, you know how much work has gone in to the return to flight effort over the last 2 years, particularly as it's applied to these 15 recommendations made by the CABE. Today, we addressed the 3 CABE recommendations that probably, and I won't say probably, that were the most technically demanding, challenging that were put forth. The 3 that related to external tank debris, orbiter hardening, and thermal protection system inspection and repair. We've known since the day the CABE report came out, even before, that those were going to be very high standards of their intent. The reason it's taken us 24 months to complete our assessment is because the agency has been working very diligently and hard in those particular areas, and the data that will support return to flight and support our assessments has continued to become available, even through the end of last week with the design verification review. So it was appropriate for us to wait till we had the best data that we could. Faced with the pending flight readiness review on schedule for Wednesday and Thursday, we chose to have our final public meeting today in order to be able to complete our assessments and deliver our assessments to the administrator before the flight readiness review. And we'll do that tomorrow. We have a scheduled meeting with him, and we will deliver those assessments at that time. That way, it's timely to a degree for him to be able to use the advice we provide through our assessments in his overall determination, looking at where the program wants to go of readiness to fly. It's also worth noting that many of the activities that we were had delayed to our assessments till today have ongoing work, ongoing beyond STS-114, certainly ongoing beyond today, even before STS-114. And we discussed that in our public meeting. But the real key is the continued effort by the agency to address the concerns that were identified in the CABE recommendations in an appropriate manner relative to the way that the program is designed to go forward, and but to not stop, but to continue their efforts toward meeting the intent of the CABE recommendations and go beyond what they've done so far. Our intent, the way that we'll report to the administrator, is with an executive summary tomorrow, and our intent is that that would be made available publicly sometime in the afternoon tomorrow. So that's our intent. We hope to be able to do that. And then in the meantime, we're going to continue to finish writing our final report, and we'll publish that as soon as we can. When it's completed, and we'll first publish it electronically, and then follow up with the ability to get a hard copy report out at some time in the near future. With that, I'm going to let Joe and Jim talk about the specific CABE recommendations that we addressed today and the disposition of those. Joe?
Okay, thank you, Dick. Appreciate it very much. It was a long, hard job for the agency to come up with the final recommendations that they're working on. Again, being from the program back in the 1978 to 80 time period, a lot of this activity was not done, and it was not done because we didn't expect to be flying in the environment that is currently that the vehicle is flying in. So they had to start over. They basically had to start over as far as understanding that environment. And the two serious problems, the fact that we had to eliminate or try to reduce the debris from the external tank, was a big challenge. The fellows and the ladies at Michoud took it upon themselves to take a step higher than the recommendations that came out of the CABE, and looked at all the debris, possible debris that came off. And as you heard today, foam was the majority of the first time period of working on that area. Ice, NASA started working on ice maybe about 2-3 months ago. And it took a while, and they're still working on trying to reduce get all the data and understand all the data on the ice. But as we are today, the foam is understood, that as far as the debris that's coming off, that they have minimized and reduced the amount of foam that can possibly come off the tank and affect the orbiter. So foam is characterized pretty good, both for the RCC and the TOM. The ice story is still coming together, but again, by analysis, the ice has pretty much cleared everything on the orbiter, specifically the RCC, and on the tiles, as they're getting very close to putting that also to bed. The ET umbilical ice issue is still an open issue, and I think what's going to happen there is NASA is going to recommend that to look at that area as far as forming ice during the filling of the tanks. They'll continue looking at that, and if any ice forms, significant ice forms in that area, they'll probably have to do something else. But right now, we think that that's basically the plan going forward, is to look at, as well as finish up the little bit of the analysis they got on ice, on the tiles. Now, as far as the orbiter hardening, we have they have fixed 4 areas, and there is one more area that looks like down the road they will work on, and that's around the landing gear doors, main landing gear doors. They will probably have to replace somewhere in the neighborhood of 200 tiles in that area. They're called Tuffy tiles. They're better than the LI 2200 that is on there at this current time. And then the other areas that they have to pay attention to is after they get in the air and fly, they're going to have to look at the areas around the external tank doors and see if they get any significant hits regarding either ice or foam in that area. As you know, they had a total of 15,000 hits on the orbiter over the period of 100 and some flights, some of them ice and some of them foam. Exactly how many are ice, how many foam, they don't know. They don't have all the data for all the flights in that area. So in final conclusion, on these 2 recommendations that our tech panel looked at, we went through about, I would say, somewhere in the neighborhood of 50 meetings to review all the data that NASA has presented, and found that they have a sound plan to go forward, finish up their analysis, and get ready for the FR, which is currently scheduled for Wednesday of this week, and hopefully resolve those open issues and get to a point of launching sometime mid-July. So, in conclusion, I think they've done one great job.
The operations panel concluded its assessments today and presented the last of the 6 CABE recommendation that it had lead on, and that's in addition to the SSP-3 raise the bar activity that we discussed last time we met. And I'm sure that most of the familiar faces in this room, and I'm pretty sure that the ones on the line that aren't in this room have been following our activities, so you know which ones I'm talking about. So I won't go back and cover all those again. But the one we closed today was 6.4-1, which was the CABE recommendation for return to flight that related to inspection and repair of the TPS. This recommendation consisted really of 4 parts: inspection and repair for missions to the International Space Station and missions not to the International Space Station. Since NASA adopted a strategy, at least in the beginning, early flights here, return to flight, of going to International Space Station, and does not currently have plans to go for other missions, we did not address the inspection and repair capability to non-ISS missions. That's something that NASA will have to address later if they have a mission that doesn't go to the International Space Station. And for the long haul, CABE, I think, intended that they would ultimately consider inspection and repair capabilities for a totally autonomous mission. The intent of the CABE with respect to inspection and repair was very complicated in this case because it is not totally independent of the other capabilities when you consider all of these in a risk reduction matrix. In other words, if you can solve the problem of debris liberation or harden the orbiter sufficiently, then you don't have to worry quite as much about repair capability. But if you've got, if there's some probability that there's going to be some debris liberated and you got to worry about some damage to the orbiter, then it turns up the temperature a little bit on how you feel about what your repair capabilities are. So while we tried to consider these CABE recommendations individually and come up with an assessment individually of whether or not they met the intent, they really had interdependencies that we had to think about. And 641 had a lot of interdependencies because when you consider all of the other recommendations with respect to imagery, photography, observations, sensor systems and wing leading edges, they all affect how well you can see damage and characterize it. And then if you consider the debris environment and the orbiter hardening issues that Joe just talked about, it starts to characterize the environment that you're working in with respect to repairing damage. And then, of course, the raise the bar activity was safe haven, and in all cases we wanted to be sure that we had repair options available so that we wouldn't have to fail down to a safe haven situation, because that's not a good option either. So we tried to keep these all within the risk reduction matrix that NASA had defined in its return to flight plan as their strategy for reducing risk. And we wanted to see, since none of these are deterministic, none of these solutions are deterministic, they all involve probabilities and uncertainties, we tried in the end to try to weigh some of these against each other. And what we found with respect to 641 is, as far as inspection is concerned, NASA exceeded what we thought was the intent of CABE. They went above and beyond the capability that we think that that was intended. They've got imagery and sensors and the OBSS. They've got the pitch maneuver on approach to the International Space Station. They have the capability of docking with the space station. In fact, they've got so much data that we were a little bit concerned that they have an integrated plan to deal with the data in a decision-making process. And so we set up a sub-panel for vehicle integration and sort of graded them on that. So with respect to inspection on 641, the operations team found that NASA not only met but exceeded what we felt was the intent of CABE. With respect to repair, we found ourselves in spirited discussions in our fact-finding, and we went back a number of times, and recently, as last time we met, we had to go back and kind of take a poll of the group and find out what people really believed the intent of the repair part of that recommendation was, and actually fine-tuned our definition a little bit of what we thought the intent of CABE was, in the context of where we thought they were headed with respect to debris liberation on the tank and with respect to orbiter hardening issues and safe haven. And what we determined to be the intent of CABE before the operations panel was, or the majority of the people in the task group could be comfortable with the intent of CABE, what could be called a repair capability. We defined that arbitrarily as that option that must have completed a formal design review. It should have gone through ground verification and testing and procedure development in an integrated certification review process before we were willing to call it a capability. Up to that point, it can be called a contingency option, or in some cases, flight crew slang would be a hip pocket procedure. Something you can determine that it's safe to fly aboard the vehicle and you can carry it up for an emergency situation, you could apply it. But we felt that it should have gone, for an option to be considered a capability, it should have gone through a process that took it through the design review, ground testing, verification, so that NASA had some reasonable degree of confidence that if applied, the repair would behave as expected. And we thought that it should go through those, the majority of the task group felt that it should go through those things to be considered a capability, or to be called a capability. So based on that interpretation of the majority of the group, we found that NASA fell short of meeting that recommendation, although they had put forth a yeoman's effort in coming up with all of the options that they could conceive of for repair. They had 5 that they're going to fly, and all of these fell into that category of what we call contingency options for repair. They've got an emittance wash that basically reduces the emittance of the tile, that they can effectively improve the thermal protection characteristics of a broken tile. There's what's called a cure-in-place ablative repair, or SPA-54, which is a 2-part cure-in-place, kind of a resin sort of material that can be applied with a gun on an EVA to fill a void in the tile. There's a tile overlay that is a kind of a late-breaking option that they've recently come up with that shows promise for future flight, but it hasn't made it through all the review processes yet, hasn't had extensive ground testing or verification. With respect to RCC, there are a couple. There's a crack repair called NOAX, which is a little putty-type material that you can put on cracks. It's not good for holes or voids, but it does fill cracks. And in the case of the second option, which is a plug repair, kind of like a molly bolt that you would put in drywall, it has to have a 1-inch hole in the RCC, and then it has a molly bolt behind it to hold it in place. And there's a sort of a high temperature rubbery kind of material that covers up to a 4-inch hole, or can cover up to a 4-inch hole, and you can use the NOAX to kind of ferret in any step or gap problems that may cause. All these options show promise for future flights, but we just didn't feel that they were tested and vetted quite enough to be called capability just yet. And what worried us was the fact that would you have the confidence that they would behave, would you have enough confidence that they would behave as advertised so that you'd be willing to fly one of these repairs home? Obviously, you would rather fly a damaged tile home with no repair than to cause more damage. So you wouldn't want to apply a repair if you thought you were going to do more harm than good. So, but on the other hand, if you thought you had a damaged state or situation that was not safe to re-enter with, you would want to be able to apply the repair with enough confidence that it would behave as expected, so that you wouldn't have to invoke the safe haven in the rescue mission. So that's kind of the tiering of options that you would like to see for these things, and that's what we were evaluating these repair options against.
Let me interrupt by mentioning something here. It took us several years to develop TPS for the orbiter. We started way back in the early part of 1970, and it didn't get operational or developed until 1980. So, and here we're trying to do tile repair, which is just as difficult as starting over again with the TPS system, and ask NASA to get it done in 2 years is very difficult. So to put that in proper perspective, TPS is a very difficult and sensitive system that we have, and it's complex like he has mentioned.
Well, like Joe said, it was a tremendous technical challenge, and while we did in the end determine that with respect to repairs, we felt that they fell short of the recommendation of CABE, or the intent of the recommendation of CABE. Our hats are off to NASA for the tremendous effort they put forth in this regard on a subject on a system that was never intended to be repaired. Like Joe said, that TPS, especially the tile, for example, is mostly air. That's why it's good insulator. And how do you repair air? It's pretty tough. And getting anything to stick to that or hold to it or fasten to it is just a tremendous challenge when you're not allowed to have any steps or gaps in the process. Tough job. And while we felt that there is a gap between the debris allowables and the orbiter's ability to withstand impacts, we think that the proximate cause of the damage to Columbia has been eliminated without doubt. There is no, we've done that, eliminated the PAL ramp. That's gone, so that's not even possible anymore. And we've significantly reduced the risk of having to apply any of these repairs through the efforts on the external tank. Bipod ramp, I'm sorry. I always get those two mixed up. I'll let Joe take care of that. So in the end, that's where we are with respect to repair. And then under the, I guess the ops panel banner, there was one other, the integrated vehicle assessment subpanel kind of flew their flag under the ops panel banner, and Christine Fox led that group, and with support from all of the other panels, it was a truly integrated effort. And the outcome of that was that NASA has come up with an integrated operations plan and an annex to support decision-making of the MMT should any of this come up during a real mission. They have a procedure in place to integrate all of the data that's going to be coming in from the cameras, from the downlinkable imagery, from the sensors, packages, all of the stuff that will have to go into the decision-making that involves characterizing and repairing or not, and what you need to re-enter with, all is planned out and has been rehearsed through the MMT process. And again, we'd like to commend NASA for the fine job of putting that together. It's a living document. It's meant to be carried on in the future as the capabilities change and grow. We expect this document to be updated and NASA to follow this procedure, and it may even become a model for other integrated assessment processes that NASA may have in that environment. So we think that they've done a great job there, and those observations about the OIP, the Operation Integration Plan, and the Annex for decision making, we'll make those observations in our final report. And that's it for ops.
Okay. Let's see, just for those of you that weren't at the public meeting, I'd like to make sure it's clear relative to the two engineering panel recommendations on our Accident Investigation Board's recommendations. Engineering panel came forward with recommendations to the task group, both for debris shedding and for orbiter hardening, that said that based upon their work and their interpretation of the CABE recommendations, that NASA had met the intent of CABE. That was not an accepted position by the task group in whole, and in fact we modified the recommendations, which were and assessments which were subsequently accepted by the task group, to reflect that for orbiter hardening, the intent of CABE had been met in part, but had not been, we had not seen a demonstrated completion due to open work that still remains based upon the debris verification review that occurred last week. And the fact that because of the shortening of the projected lifetime of the space shuttle to 2010, the program has made a decision not to pursue long-term solutions to hardening or improving the RCC, increasing RCC's hardness capabilities. We felt that that's a prudent decision that they have made, but when you look at the CABE recommendation, it is very specific about looking at ways of increasing the capabilities of the RCC. There was the task group in general accepted recommendations, said that because of that and because of the open work, that intent of CABE was not completely met by the actions on orbiter hardening. Likewise, on external tank debris, we took the engineering panel brought forward a recommendation that the intent of the CABE had been met. We got into a little bit of a box that we may have created ourselves. Based upon early implementation plans of the Space Shuttle program, which identified their approach to the intent of CABE, which was to eliminate critical debris, we accepted that as opposed to the at that time as the criteria and the intent, our interpretation of intent, as opposed to the words in the CABE recommendation, which was to initiate an aggressive program to eliminate all debris. There were several nuances there, but we, in the end, the task group decided to weigh the progress of NASA relative to elimination of critical debris against the task group interpretation of CABE, which was that critical debris would be eliminated, and we found that at the current state that the intent had not been met based upon, like I say, a task group interpretation. So in both those cases, task group, through deliberation, worked through with the engineering panel, their presentation recommendation to come to those conclusions.
Okay, I think we're ready for questions. I'd like to get through everybody once, and then we'll come back around again. We'll just start with Tracy up here, if that's okay.
Tracy Watson, USA Today, for Colonel Covey. I know it's not in your charter to decide whether the shuttle should launch or not, but I'd be interested in your personal opinion. Given what was decided today, do you think the shuttle should launch in July?
Let's see. We're here as a task group today, and I'm going to stick to the point that the task group doesn't make that determination, and so the task group will not make a determination of whether it's right time to go fly or not. We'll deliver our assessments to the administrator. He can use that as advice in his determination of that readiness. Well, I say right now we're here as a task group.
I'm Mark Carreau from the Houston Chronicle. I guess if you did a little scoring black and white, there's 3 that weren't met out of the 15. Yet I think you're trying to say that may not tell the full story. So what is the story if you look at it?
Well, see, I'll start out by saying I think you need to look at what the agency has done, not necessarily at a scorecard. And I think in our deliberations today we're very clear about the fact that everybody wants to commend the agency for what they have done and the actions they've taken. And even the ones that we said maybe not in full intent have been met, at least 2 of those, they met a good portion of the intent. And so, you know, you be careful how you score it. I don't think a scorecard is the right way to look at what's been done. That was what we were asked to do to some degree, was to make an assessment of the completion of the intent of CAPE.
Yeah, the other thing I'd like to add to that, Mark, is while we have said, for example, that NASA hasn't eliminated all critical debris, while that's true, we also say that they have significantly reduced debris. And we're very convinced that they, while they may not have fully met the intent as we have defined it, they have significantly improved on all of these things. So if you look at the risk reduction architecture of eliminating as much of the debris as you can and reducing the potential for damage to the orbiter should impact occur, and the capability to see and assess damage so that you don't have to implement a repair that does more harm, and then also have some potential repair options, all of those things add up to a total risk reduction architecture. And so NASA has to look at that. That's their job, to look at that total risk reduction and assess what risk is left over, what they term it residual risk, and decide if that residual risk is acceptable, and then they have to have a rationale for buying that off. That's their job, that's not ours.
Mark, if you're looking for a sleeper in this system, there isn't one that we can see at this time. I think it's timing that's got us a little bit ahead of the game. One is we had a DVR that completed Friday. We got the inputs on Saturday. We're here today giving you our assessment. Wednesday is the FRR. If there was some more time in between, we probably would have come in with a cleaner sheet. As you know, the tech panel did recommend a full closure on this, knowing that there is work going forward that NASA has not completed. But to look for something, like I said before, the ice story is much clearer than it appears. The analysis has been completed across the board on both the RCC and the tile. NASA has completed that, and have, other than the ET umbilical, which they're going to observe during their countdown process. So they have made a decision, NASA, to proceed with the FRR. If there was a sleeper in the system, they would have probably not have proceeded with the FRR as scheduled.
Yeah. Bill Hart with CBS. I think maybe for Jim, I just want to take another crack at Mark's earlier question. I mean, I think there's probably a bit of a contradictory message that comes out of an event like this when you officially say that they haven't fully implemented what many of us would consider the top 3 recommendations for return to flight. And yet at the same time, the message is, but they've done a great job, and maybe as best they could reasonably do. But can you help me maybe just try to, what's the message that the public should take out of this, given these red lights and given what you're saying that they have in fact accomplished?
Well, unfortunately, you know, we were asked to make a determination that's binary, yes or no. The actual issue of trying to reduce debris and harden the vehicle and come up with repair options is not a binary problem. It doesn't lend itself to a binary solution. It's actually ranges of completion and uncertainty boundaries around numbers. So it turns out to be relativistic. They're relative to each other, and they're also probabilistic. And in other words, what's the likelihood that you're going to have some damage come off? Well, it's much lower than it was. And so while we can say that technically, or in our opinion, in the task group's opinion, they may not have fully met the intent of CABE, we're also saying that they have made significant progress toward reducing the likelihood that any of these things, these bad events, will happen. So what's left for NASA to do is to put these things all together in a risk reduction architecture and assess what they believe to be the residual risk before they fly. And I'm sure that's what they're going to do.
I think another way of looking at it too is what Dick mentioned. One of our charters, part of the charter is operational and safe of the vehicle when it flies. And we have assessed that from NASA's inputs to us, and we feel that it is a safe vehicle to fly based on their inputs, and they made that statement too. So that's where we're coming from. Now, the CABE recommendations has words in there that says, thou shall do this, and me doing these kind of things, and we have not answered per the word of the CABE. But from an operational readiness to fly, the data they presented to us so far says it's safe to fly.
CABE wanted to break a chain of events that happened on Columbia. CABE, that's what CABE really, I think if you really get down to the heart of the intent of CABE, they were trying to break a chain of events. What happened is a piece of debris gets liberated. It has just the right transport mechanism. It impacts the orbiter in the right place, causes damage that needs to be repaired, and there's no repair capability. And there's no ability to actually see and characterize the damage. All of those things added up to conspire against Columbia. And what CABE was really trying to tell us, I think, was that we've got to focus our effort in these four areas of reducing the debris, taking or making the orbiter more impact resistant, being able to see and characterize the damage, and then if you got some, fix it. They wanted to see all NASA's efforts focused in those four areas to reduce the likelihood that that event could ever happen, and I think they've done that. That's exactly what they went off and did. And the fact that in each one of these taken independently, we might find some semantics in their wording that says we don't think that they fully met the intent of this one. Overall, it's significantly reduced the risk.
And I might add, we may have made our job harder than it needed to be from the standpoint of in order to get people to sign up to do this, we intentionally focused on 15 return to flight CABE recommendations, and we said that we wouldn't question those CABE recommendations, just like the agency said they wouldn't question the CABE recommendations. As we know, things have changed over 2 years that might have affected the way that you looked at those recommendations if you hadn't said that. So, we're looking at each of the recommendations in a binary fashion to some degree. Although, as Jim says, some of them we've looked, because they touch each other, we've looked at them together. But we may have made our job harder. And consequently, and quite honestly, we were trying to stay away from being someone that gave a thumbs up or a thumbs down on whether it's okay to fly. We weren't going to do that. So we said, what can we do that's of value? And that's to look at the actions taken by the agency in response to those 15 recommendations that the administrator said we're going to go implement. And so we made our job harder by doing that and focusing in on the way we did, rather than maybe a more holistic way of saying, okay, what did the CABE really want to do? Did they want to attack the chain of events by hitting it to different places and break that chain? And could we have done an assessment more holistically like that and come up with a different answer that said, that the intent of CABE had been met in a general nature? Well, that's not the way we did it, and that's not the way the CABE reported it. We had to go down and focus on those individual ones. And so, our response and our assessments really have to be taken in the context of what they are. And that's why I refer back to the point of you have to look at what the agency's done, the progress they've made, and is it a miss is it a miss if you're at 95%? And I think Joe said it right, is that we haven't seen anything that says that the progress they've made is of concern relative to the safety of the vehicle.
Mike Cabbage with the Orlando Sentinel for Mr. Covey. Sort of a follow-up to Tracy's earlier question. You flew on the mission after the Challenger accident, returned to flight the first time around. And I was wondering if you could compare, going into that mission, the uncertainties and how well prepared you think the agency was to return to flight with this time around. And I'll repeat Tracy's question also, just for the heck of it. Would you be willing, after having done this once before and based on your unique knowledge of this, would you be willing to go fly on 114 if you were assigned to that crew?
Okay, let's see. Relative to the preparation for STS-26 and that return to flight activity, the major difference is that, in my mind, is the ability to actually test the changes that were made to address the specific cause of the accident. And in that case, you could fire a solid rocket booster with cut O-rings out in the desert. Can't take the external tank with the changes that have been made to eliminate debris and put it in a wind tunnel. We can't do that. So you have to go fly to do that verification of the changes that you've made. In this case, it's not insignificant. It's a significant difference. At the same time, the tools that are available to do analysis and what has been done in terms of modeling, simulation, testing is extraordinary from the knowledge that we have. And all of that has been put to good use by the program in doing their risk assessments and then trying to put it within the structure that Jim's talking about of is the risk acceptable. From the standpoint of would I be ready, based upon what I know, to go fly on STS-114 if I were a young flying person, I would not have a concern about flying.
John Kelly from Florida Today. For Colonel Adamson and for Mr. Covey, you guys talked about carrying forward with ASAP. Could you talk a little bit more about that, what you're hoping maybe that they can do, maybe taking forward some of the things that you worked on and making sure that there's some continuity or perseverance, I guess, on some of these safety issues?
Well, let's see, I don't know if there's specifically safety issues, but if you take organizational change, the plan coming into return to flight was to have a plan in place. Of course, they progressed much further than that. They've implemented most of the changes, but those organizational changes are some of the things that CABE saw as symptomatic of the way that the agency had changed between the return to flight effort after Challenger and the Columbia accident, and so that'll be one of the things we'll say is that the CABE or the ASAP needs to continue to monitor the way that the agency has implemented organizational change and to assess if it's effective as it was intended by CABE. That's an example.
There are plans that are out there, such as a plan of how to put the foam on the manual areas. These plans must be followed up by the safety advisory panel to make sure that they go in there and see how they're doing, going down to the chute, checking it out. So there are plans that are required to be monitored down the road, and we're turning over those plans. They're part of our report. They would be part of their responsibility to take a look at them. And we also have some observations. Those two will be monitored, and we'll pass them on. And I believe the date is set for August 14th or something like that. That we're meeting. Yeah.
And we probably should just say that we've been a little fast and loose with throwing things to the ASAP. panel, we really don't get to tell them what to look at. You know, we do have an MOU where they take our recommendations and consider them. But I'm not, you know, NASA really kind of directs them, and so they're going to have to. I'm not even sure they're capable of doing all the things we talk about in their name. But really, we probably would be better to say that NASA should follow up on some of these things.
Okay, John. John Schwartz, the New York Times. I was wondering, from our vantage point, it seemed that y'all were possibly a little bit surprised that you went 0 for 3 today, ultimately. And I was wondering,
2 for 3, at least. They overruled me.
2.5 for 3. I'm asking for characterizations.
That's correct. 2.5 for 3.
And a little bit pregnant. But I'm wondering whether you were surprised and whether and how you see this going forward. You've already said 2.5.
Well, I'm never surprised with this group. As we learned more this morning and understanding the fact-finding had taken place, there was a growing feeling in my mind that we might go 0 for 3 when we got into deliberations on these. And again, it's not 0 for 3 because it's partials in there too. If you want to take a binary look, which you're totally entitled to, but it's the wrong look. It's the wrong way to look at what we did today.
Okay, do we have other questions? Mark.
Mark Carreau from Houston Chronicle. Just a kind of a housekeeping question on the ICE and the LCC. I think I heard it called ICE in the ET umbilical, and there's also orbiter umbilical. Where is this ICE, and how closely do they need to look at it? What's going to be the trigger point when they have too much, as far as you're concerned, if you want to take a swing at that?
Well, it's on the ET umbilical to start with. It is on the base of the ET umbilical. The criteria that exactly what they're looking for and how much ice has not been brought forward to us at this point in time. And we're waiting to get that data, but it's on the ET side of the umbilical. And they have seen ice here before, and they are, and during the countdown and the loading the last time, they didn't see any ice forming, but that was a good day. So that was not a criteria that they can use, but they're working on it to come up with what is the right requirement for how much ice is going to be seen in that area. And if they get more than that criteria, then they'll have to do something else. And they're going to do this by visual, taking a look with the binoculars and see. They have an ice team that will examine and see if they have significant ice. And if they have significant ice, they're not going to fly.
Okay, last question. One more here.
Bill Harwood, one more for Jim, if I could. I realize that it is what it is, and you guys were talking about timing earlier, Joe, as being a little bit of a perception issue here. But I mean, I guess I'm wondering, if you delayed this launch, not you, but if NASA delayed this launch to the next window in September, is that by an incremental improvement in your mind in terms of completing these open items, et cetera? In other words, is there anything to be gained by slipping a window? In other words, is there some reason that would not be a good thing, or the opposite?
I thought that it would significantly reduce the risk by slipping from this point. I would definitely say that. I don't believe it would, because a lot of this stuff is dependent upon flying to find out what you don't know, and we need to fly to learn how to modify the work that's been done and continue it. So my answer to that is no.
The slip from May to July was a good thing from the standpoint of the forward ET umbilical, not the umbilical, but the LOX bellows. Putting those heaters on was a real smart move, and I think that was justifiable. But looking downstream, I don't see, NASA doesn't see any hardware changes at this point in time that's necessary. And that was another ruling that came out of the DVR meeting. Was there anything that would affect the hardware? And at that time it was said none, just analysis that got to be completed.
Okay, it's been a long day for everybody concerned, and so I think we'll go ahead and wrap this up. We'll have about a minute and a half of B-roll after we conclude, but offer Dick any closing comments.
Sure. Well, it's been a long journey for NASA from the Columbia accident to the point they are now getting ready for a flight readiness review. We have, I think they would characterize us in different ways. I don't think we have been particularly their buddies. I think we have been demanding on the Space Shuttle program in our quest to understand and to quantify the actions that they have taken relative to the CABE recommendations. I believe we have been a relatively harsh judge of those activities, as we discussed today. And as you saw, not all 26 people necessarily agree on whether the intent wasn't met. And today, in that case, that there's some additional that we work toward a consensus and an acceptance of a group position, and that's what we got today. And I was pleased with that. Task group members have put a lot of time into this. I'm particularly appreciative to them, to our staff that has supported us diligently and done a lot of the legwork for us, and is helping us finish up. So we appreciate the opportunity to be able to help NASA as it returns to flight. And as we deliver our advice to the administrator, we know he will put it in the right context. He will look at it in terms of what NASA has done to prepare itself to fly again, in our interpretation of that. So thank you.
Work ahead really now comes down to understanding the remaining risks that we have in terms of our debris environment and our capability of the vehicle, which we're going to be evaluating as we move into our debris verification review coming up next week at the Johnson Space Center. And then really just taking care of all the documentation and paperwork that's in front of us. There's quite a bit of that, but we've got a plan, and we think we can get it all accomplished in time to support the opening of the window in May. Well, for me as Orbiter Project Manager, this being my first opportunity to come down in this capacity, this was great. I've been down here before in other capacities and have seen a rollover to the VAB, but it's nothing like the first time.
What went through your mind when you finally first saw it move and started the journey down the road?
Well, my mind went back to the day I was asked if I was willing to take on this job. And at the time I questioned, was I the right person for the job? I think we would all probably ask ourselves that question. So to see it roll over and be in a position I'm in was very, very fulfilling.
And how much safer is this vehicle than shuttles that have flown in the past?
Well, I don't have a quantified number to provide, but in terms of everything that we've done, I think it is the safest vehicle we will fly.
And what makes it safe?
Well, if you look at all the inspections that we've done across the entire vehicle, like the reinforced carbon-carbon that I've talked about already, the landing gear door work that we've done to ensure that we have proper sealing, both from the thermal barrier and the pressure barriers, and then all of the different sensors that we've added into this system, overall capability. It's order of magnitude better in terms of capability to ensure we have the safe vehicle to come home with.
How does May 15th look for a launch date? How much contingency time do you have now?
I would defer that question to Stephanie and her team. They'll be working the final flow processing. I think from a program perspective, we're going to be looking at the tanking test that's going to happen on April 14th, and then take a step back and assess where we really are against our schedule, and then try and put a firm, definitive date out there that we can go ahead to the Spaceflight Leadership Council with. But right now, I think 15th is doable, but things will have to align just right.
Discovery? Yeah. Well, we have to check it every time. We never have to really adjust it. We never had to adjust it. No, I don't know. It gives you plus for
Well, welcome and greetings from sunny Florida. We've had just a wonderful weather down here in Florida, and the Kennedy Space Center team readies Discovery for the rollout to the pad. This is a pretty exciting day for us as we get prepared, and we'll be ready to roll out tomorrow morning pretty early. We have a little video we want to show, and I'll narrate that a little bit for you. And so go ahead and roll the video, Kyle. Late last year, we got the engines installed in Discovery. That was a huge milestone for us. It was a great effort by the Boeing Rocketdyne team, and of course the Kennedy Space Center processing team as they readied the vehicle for that installation. Some other things we did late last year was the OBSS was delivered from McDonnell Detweiler up in Canada, and we were able to get that installed in Discovery as well. Again, a great effort by our Canadian partners, getting that down here to us, getting that built, and then the Kennedy Space Center team installing that. And this is a depiction of how that will be used on orbit. It'll attach to the shuttle arm, and then we will scan the leading edge of the wing as well as the underside of the tile. It's gonna, I believe it will work just perfectly. Also, you see the crew came down and took a look at the leading edge of the wing, but really most important is we have a baseline for all this tile and RCC, all the thermal protection system. We've taken pictures of it. We've taken a number of different kinds of shots, and we have a really good baseline. I had the opportunity to tour the crew around a little bit and talk about some of this hardware. It was a great interaction. I was glad to hear how they were doing in their training and see where they were at. We were down in the VAB when the external tank was lifted up and integrated with the solid motors. Again, another huge milestone earlier this year in which we were readying Discovery for rollout to the pad. And of course, the big milestone was Discovery rolling out over to the vehicle assembly building, where we will lift it and install it with the entire stack as we readied it to roll out. And I think Mr. Reedy was down here for that, and I think the folks just had a great time that night actually. There's some footage here of it getting in the VAB and the sling being attached to the orbiter, and then the lift occurring and taking it up and over and integrating it with the stack. They do this. This is a pretty slow maneuver, and they capture this on video, but I think I kind of rushed through that. I apologize. And there's nothing better than seeing this orbiter in the vertical finally, and the lift and eventually integration with the solid motors and the external tank. And you can just see what a great operation this is. We haven't done this since December of 2002, so we were real proud to be able to do that operation and ready the vehicle for rollout to the pad. I tell you, I just want to explain to you that thousands of people have readied this vehicle, not only here at the Kennedy Space Center, but all the work over the last 2 years getting this vehicle ready to be rolled out to the pad. And I believe, just as Bill Reedy said, this is the safest vehicle we've ever flown. We know a lot more about this vehicle than we did when we started 2 years ago after the accident. As Bill said, you can never eliminate all the risk in human spaceflight, but I think this team has been very diligent, very rigorous in how we've approached the processing and the engineering and the redesign of the different elements of this vehicle. And I believe that we're ready to roll out, and we're ready to go launch in the May timeframe.
And we have confirmation of first motion at 2:04. Exact time was 2:04:36 p.m. Eastern Daylight Time. First motion is very minuscule as it begins to roll away from the pedestals on which the mobile launcher platform has been resting in the vehicle assembly building. until they clear the vertical doors of the high bay at this time, it appears that's not going to happen. Everything is continuing to go very smoothly. And we can just see the crawlerway there outside the door above the tip of one of the solid rocket boosters. About 30 crew members on the transporter as it rolls to bring gravel to the surface that has not been crushed, and every now and then fresh gravel, fresh stone is brought in.
tank beginning to arrive at Kennedy Space Center after a 900-mile journey at sea. It departed NASA's Michoud Assembly Facility in New Orleans on December 30th. It is transported via Pegasus, NASA's specially designed barge. The solid rocket booster retrieval ship Liberty Star brought the barge to Port Canaveral January 5th of this year. On January 6th, the barge was moved by tugs to the Kennedy Space Center turn basin. The tank was then offloaded and transported to the vehicle assembly building. Here you can see the tank being transported on its transporter. That is the way it arrives on its transporter from Michoud Assembly Facility and is moved into the vehicle assembly building where it sits on that transporter until it is raised into its checkout cell. In the vehicle assembly building, the tank was raised to the vertical position, lifted high up in the transfer aisle, and into the checkout cell, where the tank's mechanical, electrical, and thermal protection systems were inspected. The tank also underwent new processing resulting from its redesign, including inspection of the bipod heater and external tank separation camera. You can see technicians beginning to apply a foam spray that we do here at Kennedy on the aft hard point, and that particular area is where the external tank sits on the transporter as it travels on its journey. The tank was prepared for attaching or mating to the shuttle solid rocket boosters. The tank was slowly lifted from the checkout cell and moved across the transfer aisle in the vehicle assembly building into High Bay 1. Once it arrived in the high bay, it was lowered and attached to the boosters, which are sitting on the mobile launcher platform. The external tank was lifted by the crane on February 28th and joined to the already stacked boosters in the 52-story vehicle assembly building. Prior to when Orbiter Discovery joined the stack, final closeouts on the tank including attaching the new bolt catcher and electrical cable connections, an aerodynamic fairing and the bipod struts. The attach points for the nose of the orbiter to the tank were also installed. You are now seeing a picture of the external tank mated to the solid rocket boosters in preparation for Orbiter Discovery coming over to be mated. This is a picture of Discovery on the way to the launch pad leaving the vehicle assembly building. Discovery's journey was a slow and careful one. The fully assembled Space Shuttle vehicle stack that includes the orbiter, the external tank, and the twin solid rocket boosters was mounted on the mobile launcher platform. The whole assembly was carried to the launch pad beginning the afternoon of April 6th and arrived at 12:30 a.m. on April 7th on a vehicle known as the Crawler Transporter. The crawler's maximum speed during this 4-mile journey to Launch Pad 39B was less than 1 mile per hour. In all, Discovery underwent 41 major modifications in response to the Columbia accident, including work to address the recommendations of the Columbia Accident Investigation Board. These included adding the new orbiter boom sensor system, which equips the orbiter with cameras and laser systems to inspect the shuttle's thermal protection system or heat shield while in space. Installing sensors on the leading edges of the shuttle's wings, a new safety measure that monitors the orbiter wing for debris impacts, and also adding a new digital camera to view the external tank during launch. Launch of Discovery for its return to flight mission, designated STS-114, is targeted for May 15th with a launch window that extends until June 3rd. During their 12-day mission, Commander Eileen Collins and the rest of the Discovery 7-person crew will test new hardware and techniques to improve shuttle safety. This is Shuttle Ground Operations Control. Space Shuttle program managers are in Firing Room 3 in the Launch Control Center at NASA's Kennedy Space Center in Florida. Today, a pre-STS-114 tanking test is scheduled to test shuttle hardware associated with filling the external tank and to condition the main propulsion system. Filling of the external tank with liquid hydrogen and liquid oxygen was to begin this morning around 5:30 a.m. However, program management wanted to get a weather update at 7:30. They were watching some thunderstorms that could possibly be in the area this afternoon before they made the final decision to tank this afternoon. Program management at 8:11 this morning made the decision to proceed with tanking operations today because the probability of thunderstorms was not high enough to keep us from tanking the vehicle. Both the liquid hydrogen and liquid oxygen are held at a propellant storage facilities at the launch pads. A 900,000-gallon tank stores the liquid oxygen at minus 297 degrees Fahrenheit and is used as an oxidizer by the Space Shuttle main engines. A similar 850,000-gallon tank stores liquid hydrogen at minus 420 degrees Fahrenheit. The tank weighs more than 57,000 pounds when empty and about 1.6 million pounds when loaded with propellants. The liquid oxygen tank volume is 19,463 cubic feet and contains approximately 1.38 million pounds of oxidizer. The liquid hydrogen tank volume is 52,371 cubic feet and contains approximately 231,000 pounds of propellant. The beginning of the tanking test began at about 8:14 this morning when we began to fill the external tank with liquid hydrogen and liquid oxygen. It takes about 3 hours to completely fill the 526,000-gallon tank. The external tank will fly on mission STS-114 with several modifications, including 2 new forward bipod heaters at the forward attached fittings that connect the tank to the orbiter. Following the Columbia accident on February 1st of 2003, NASA and Lockheed Martin Space Systems companies spent nearly 2 years modifying the tank to make it safer. The external tank is the largest element of the Space Shuttle system, which also includes the orbiter, the main engines, and the solid rocket boosters. It measures 27.6 feet wide and 154 feet tall. Despite the tank's size, the aluminum skin covering it is only 1/8 of an inch thick in most areas. Yet it withstands more than 6.5 million pounds of thrust during liftoff and ascent. The tank is the only shuttle component that cannot be reused. The test began with propellant loading and will continue through stable replenish. Once the tanks are about 98% filled, technicians slow the flow of propellant, called topping the tank, until the tank is filled to 100%. However, because the tank is warm and the propellants are cold, some of the propellant burns off. Therefore, propellant must continually be added to keep the level at 100%. Stable replenish is the point where the technicians have stable control of the propellant entering the tank, keeping the level at 100%. The stable replenish phase is planned for approximately 3 hours for the tanking test today. As the tank cools, the fluid becomes denser. By continuing to add the propellant, it packs or squeezes more propellant into the tank. Once the tank is filled, technicians terminate the replenish phase, and the tank and propellant are configured for simulated launch. The normal countdown procedures will be performed at T-minus 31 seconds. During countdown, the mechanisms that feed the fuel and oxidizer into the main engines will be evaluated. This procedure also conditions or cools and fuels the engines and readies them for ignition. You are seeing live footage of Space Shuttle Discovery at Launch Pad 39B at NASA's Kennedy Space Center, where it is undergoing a tanking test that began at 8:14 a.m. when we began to load liquid hydrogen and liquid oxygen into the external tank. The Space Shuttle vehicle and ground systems will be subjected to the launch countdown environment without the transition to auxiliary power unit start, Space Shuttle main engine start, and solid rocket booster ignition. Although the tanking test is not required for certification of the external tank and the associated return-to-flight redesign, without a tanking test, launch day would be the first time in over 2 years that NASA would have exercised the cryogenic loading systems and the external tank thermal protection system inspection. The pre-STS-114 integrated tanking test will demonstrate the performance of ground systems which have undergone design changes and allow time to react to first-time occurrences and anticipated observations that are a result of the tanking. Following the completion of tanking operations at about 11:30 a.m. this morning, the ice debris team will enter the pad to begin their inspections. The team includes 8 members and is comprised of personnel from NASA, United Space Alliance, and Lockheed Martin. The team will be evaluating the tank under cryogenic conditions and will be looking for frost and ice buildup on the tank. Although ice is expected to form on the external tank during the tanking test in the areas that have traditionally grown ice, the team has updated the ice debris inspection criteria based on ice characterization testing results from tests done at various centers throughout the country. The ice debris team will be entering the pad at about 11:30 a.m. this morning. The team plans to take about 2 to 2.5 hours to perform the inspections. The inspections will begin on the mobile launcher platform 0 level. The team will then move to the 255-foot level and proceed down the fixed service structure to the 215, the 195, and the 135 foot level, and end up their inspections back on the Mobile Launcher Platform 0 level. This is Shuttle Ground Operations Control. Space Shuttle Program Managers are in firing 3 at the Launch Control Center at NASA's Kennedy Space Center in Florida. A pre-STS-114 tanking test is underway and proceeding very well. We finished filling the external tank with about 526,000 gallons of liquid oxygen and liquid hydrogen at about 11:04 a.m. this morning. The tanking test was to be underway at 5:30 a.m., but program management wanted to get a follow-on weather update at 7:30 a.m., which delayed the beginning of tanking to a little bit later this morning at about 8:04. You are looking at a live shot of Launch Pad 39B. The ice debris team entered the pad at about 11:18 a.m. and performed nearly 3 hours of inspections of the fueled external tank. The ice debris team began their inspections on the Mobile Launcher Platform 0 level, moved up to the 255 foot level, and then moved down the fixed service structure. They moved to the 135 foot level at about 1:22 p.m. this afternoon, and then on to the 0 level of the MLP for their final inspection point at about 1:36 p.m. this afternoon. The ice debris team is currently exiting the pad and is on their way back to the firing room to brief the management team on their inspections. The ice debris team did report that the vehicle and external tank appear to be in good condition throughout the tanking test. In the firing room, the team is continuing to move through the simulated countdown until the T-minus 31 second mark. The stable replenish phase is planned for approximately 4.5 hours total. As the tank cools, the fluids become denser. By continuing to add propellant, it packs or squeezes more propellant into the tank. Once the tank is filled, technicians terminate the replenish phase, and the tank and propellant are configured for a simulated launch. Again, the team is proceeding through the simulated launch countdown until the T-minus 31 second mark, which will occur at about 4 p.m. this afternoon. Once the countdown has been completed, the external tank will be drained of the liquid hydrogen and liquid oxygen. That process takes about 2 hours to drain the tank. Although the tanking test is not required for certification of the external tank and the associated return-to-flight redesign, without this tanking test, launch day would be the first time in more than 2 years that NASA would have exercised the cryogenic loading systems and the external tank thermal protection system inspection. This pre-STS-114 integrated tanking test helps to demonstrate the performance of the ground systems, which have undergone design changes, and allows time to react to first-time occurrences and unanticipated observations that are a result of the tanking. The team evaluated the tank under cryogenic conditions and looked for frost and ice buildup on the tank. Although ice is expected to form on the external tank during the tanking test in the areas that have traditionally grown ice, the team has updated the ice debris inspection criteria based on ice characterization testing results from tests done at various centers throughout the country. Since the beginning of the Space Shuttle program, there have been 8 previous tanking tests similar to this one. 7 were tested during the first years of the Shuttle program, 1981 through 83, and 1 was tested prior to flying the first super lightweight tank. Again, you are looking at a live shot of the launch pad 39B at Kennedy Space Center, where a tanking test for return to flight is underway. The ice debris team has completed nearly 3 hours of inspections and are on their way back to the firing room to brief the management team. And the ice debris team has reported that the vehicle and external tank appear to be in good condition.
Good afternoon and welcome to our press conference regarding today's STS-114 external tanking test that took place at NASA's Kennedy Space Center earlier today. We appreciate your continued interest in America's Space Shuttle program, and thanks for joining us. Today we have 3 distinguished leaders with NASA to discuss the activities. First, Wayne Hale, NASA's Deputy Space Shuttle Program Manager, Mike Leinbach, NASA Launch Director, and Neil Otte, Chief Engineer of the External Tank Project Office. They'll have opening statements and then we'll take your questions. Wayne?
Well, I'm always pleased to be back down here in Florida. I think all the really wonderful things in the space program always start in Florida. And it's great to be at the Kennedy Space Center. We had an outstanding day today. After a long period of time of preparation, we are beginning to see our operations come to fruition. Today we saw the newly modified external tank perform in an outstanding manner. Neil's going to tell you a little bit more about that. We saw Discovery, which has gone through about 3 years of modification, if memory serves correctly, perform in an outstanding manner. And I have to also say that the launch pad, the facility, which has gone through a major modification and extensive rework, performed almost without flaw of any consequence to talk about, and I was extremely pleased that it worked well together. There was a good exercise for the mission management team to come down and watch the activities. The new tools that the ICE inspection team had worked very well. And all in all, I couldn't be happier at the conclusion of today's test. I think it puts us on a really excellent course to be ready to go launch here in the next few weeks.
Thanks, Wayne. Mike?
Well, I couldn't be happier. The test went off virtually without a hitch today, and I'm just happy that the launch team and the Kennedy Space Center were able to put on that test for Neil's new tank, and you know, we haven't exercised our ground systems for quite some time too. So not only did we exercise the new tank, we made sure that the ground loading systems for the cryogenics and other systems were up and running and getting ready for launch next month as well. Launch team performed very, very well. So we met all of our objectives today. It was excellent training for us, and just a great day. Another major milestone. I mean, we've hit some major milestones in the last couple of weeks here at the Kennedy Space Center. Rollout was major. Today's test was a major milestone. The next one is launch, and I'm really looking forward to that one.
Thanks, Mike.
You know, I'd like to start by thanking Mike and his team. You know, full-service stations aren't too easy to come by anymore, and they not only fill your vehicle for you, they drive you up to the pump. So they did a real good job and performed very well. We, of course, were very interested in the performance of our redesigns. Primarily, the bipod heater got a good workout today. The data came in, it was right down the middle of the line, performed and looked just exactly as we expected it to do. So we're very satisfied with that design. Also took a hard look at the closeouts that we redesigned of the foam and that we had put back onto this tank. That was in the longeron region, the flange region between the inner tank and the hydrogen tank and the bipod. All of those performed very well. We had no issues whatsoever with those. That foam behaved pristinely, and we saw no indications of any problems at all in those closeouts. Also, the bellows, the drip lip configuration that we have modified and put onto this tank, it also, the ice that formed around the bellows was very minimal today, and we're very, very pleased with the overall performance of the tank.
Thanks, Neil. We'll now take questions. As always, please identify yourself and your media organization and who you're directing your question to. We have media standing by at other NASA centers, so we'll work them in as well. We'll take a question and a brief follow-up, but please, as always, none of those A, B, C, and D questions. And we'll start right here with Marcia.
Then Associated Press for either or all. Can you say then, beyond a doubt, that the tank has passed the test? And how would you grade it if it did pass?
Well, I think from our standpoint, we'd say we got an A. Now, you know, we got to look at our bosses to get the final grade, but it performed exactly as we expected it to perform. We were very pleased.
Okay, Stefan. Stefan for New York Times. So, in essence, you could have launched today, weather permitting?
Well, there were a lot of systems on board the shuttle and the SRBs that were not powered up today, so we were obviously not in a flight configuration today by any means. But everything we needed to do for Neil's external tank was up and running, and as he said, it was right down the middle from my perspective on the launch team. And so every test objective that we laid out, and that included some beyond just the external tank, again, we had objectives for my launch team, for the final inspection team, to verify their inspection criteria document that's been updated somewhat due to his redesigns. We verified that today, so I can't think of a test objective that wasn't met today, frankly.
We were in the mission management team where we have a number of former astronauts trying to put together a pickup team to go get on the vehicle. It was that good. I would remind you, however, there is traffic at the International Space Station tonight. Our friends at Baikonur launch in just a few hours, and so they probably would prefer us to wait until they're clear the area.
Okay, Bill.
Bill Harwood, CBS for Wayne. I'm hoping you can maybe put the test in the context of the debris verification review, which you guys wrapped up Saturday. I know that you went through 100 and whatever items it was, and I guess there were 2 or 3 that were left open, mostly regarding ice, I guess, around the drip line, around the bellows, and I guess up at the top of the tank. Can you let me know what's still an open item from the DVR? I know the DCRs had to move the next week, I guess, and you're going to do a Delta DVR. If anybody's listening to this, they're going to have no idea what we're talking about, I guess. But can you tell me how that all plays into the flight readiness review, Stafford Covey, and all of that?
You sure you weren't in the meeting when we were there? Okay. Let me see if I can. We did move the program design certification review to next Tuesday. Part of that was to deconflict with people who are traveling to Russia, but it certainly gave a couple more days to close out some items. The debris verification review that we had last week in Houston for 3 very full days was an extensive review, and we closed many of our concerns about ascent debris. You're right, we have 3 or 4 that are going to remain with us that we're going to continue to do some testing as we get closer to launch, and will be talked about at the design certification review and probably closed out at the flight readiness review. Ice is a biggie. One of the things we were very interested to look at today was the performance of the tank and ice growth on the tank. It performed very well. That is heartening news, but that is not all the story. We're doing some testing at the Redstone Arsenal and other places regarding potential for ice to shed off the tank during the ascent, and we think that there is a number of ways that we're going to come to a good conclusion on that, so we're pressing forward. But there is work remaining before us on about 3 items.
The follow-up was built into the question was, though, the process for reporting out. I mean, do you guys report to Stafford Covey before the flight readiness review? Are they concurrent, or how does that work?
Some of those details are being worked. We will have another plenary session, I'm told, with Stafford Covey. I don't have all the details. That will probably occur between the design certification review and the flight readiness review.
Okay, we'll take one more question from here, and then we'll start going to other centers. Todd?
Todd Halverson of Florida Today for Mike Kleinbach. Mike, I wonder if you could discuss the schedule, how much contingency you have to make the 15th, and whether you're considering adding contingency days in at this point to the schedule.
Well, from here, leading up to May 15th, we have 3 days on the schedule where we have no work planned at the launch pad, so that's good news for us. Even better news for us is that the test we performed today was the last non-standard activity we have at the launch pad. From here on out, it's standard pad processing. We're going to be loading the hypergolic system, our ordnance system, testing out the various other systems and loading the payload at the end of the month. We have our terminal countdown demonstration test with the crew on the 29th of this month. So from here on out, the rest of the pad flow is well understood and nothing unique coming up. So the fact that we have just 3 days, if you want to say it that way, is not that bad. We have well understood work ahead of us. We're not planning on adding any days to that. We're going to shoot for getting our work done to support the program whenever they want to fly, as early as the 15th.
Just a real quick follow-up. I'm wondering if you can give us your confidence level in making the opening of the window on the 15th.
Well, let's see. I would quote my boss, Bill Parsons, who I think told you last week it was 50-50. I wouldn't go past that. We certainly have a lot of work to do. I would say that the work that we have to do is not just discovery. We have to get Atlantis ready to fly in time for the rescue mission if it's required. There is quite a bit of work. We're going to be reviewing that in the next few days. We also have a large amount of engineering, what we call engineering paperwork to close, which is important back at the design centers because that shows that you have done the process and that diligence has been followed in completing the engineering analysis that proves that we will be safe to fly. So there's a lot of work here at the Kennedy Space Center, but there's work in other centers as well, which has got to be complete before we're ready to go fly. Let me remind you, I don't want to get in one of these launch date discussions because from 2 years ago, we have consistently said that we're going to fly when we're ready to fly. We have an opening of the window that's dictated by orbital mechanics on May the 15th, but if our work indicates that we need to take more time past that, we will do so because we are going to be driven by having our work completed, not by some date that shows up on the calendar. We've looked very hard at the launch window, and it goes out to June the 3rd. Certainly getting off in that launch window anytime would be considered to be a very successful thing. We've even talked about, is the 3rd the cutoff date. It's not a crisp cutoff on lighting. There are some, you could probably talk about a couple more days if you got in a situation. And then there's the July window. So we are working toward May 15th, but we are not being driven by that date to do something that is inappropriate.
Okay, now we'll go to NASA headquarters for a question and a follow-up.
Tracy Watson with USA Today. So do you think you're going to fly this tank on STS-114 as it is without any further modifications?
The short answer, I think, is yes. Neil, do you have any further work that you're planning on the tank?
We don't, Wayne. All we are going to, as Wayne said, we're finishing out all our series of reviews that we've got to get through, make sure that we've got the proper rigor in our certification and supporting the system in all of their reviews, et cetera. And until we get new requirements, we got a tank that as of today, we say meets all the requirements, and we'd be ready to go fly it.
Quick follow-up for you. Can you talk about how much ice you saw on the tank and whether the weather conditions today were conducive to ice formation?
And the ice that we saw today was very minimal. The weather today was, the humidity did fluctuate a little bit. It was fairly low. Temperatures were mild. We had a good wind. We would not have anticipated large amount of ice on the tank today. But we knew that going in. We know that any tanking test was going to be one data set. That's why we do testing at the certification range, within controlled environments and controlled tests to go after certification. So this was a good confirmation that the tank behaved as we anticipated it to behave, but we certainly didn't stretch the range of our certification or the range of the weather that the Cape can throw at us as we proceed on.
Okay, we'll go to the Johnson Space Center.
Thanks. This is Mark Carreau from the Houston Chronicle. I have a couple questions. The first is for Wayne Hale. Can you probably heard NASA's new administrator, Mike Griffin, today say that his #1 task is to close out the issues remaining on the return to flight. Can you say whether the test today, the debris verification review work that you did late last week and that you anticipate doing will help with that task?
Okay, I did not get very much chance to listen today to the administrator because we were occupied, and but I do know from the confirmation hearings that he said that he was very interested in what we've done and wanted to get up to speed with the shuttle program in very short order. So I think we'll probably be talking to him very quickly. I would say that, yes, Mark, you're correct. Both of the design, the debris verification review, the upcoming design certification review, and this thinking test that we did today are key items on the way to being ready to go fly. We're not done yet, but these are key things that we needed to get accomplished. We're whittling down the to-do list of things that we must do before we feel confident that we can certify the vehicle for flight readiness.
And just to follow, as I understand it, at this point, you're sort of driving with the work outstanding when the task group would be able to make its final plenary and do a review. Do you have a sense of when you would be ready? And I know that's hard to ask you a date, but I'm asking for a sense of a couple weeks, end of this month, early next month. You know, in light of all that you've said about not being schedule driven, I want to respect what you're saying, but I'm trying to get some sense of where this is headed.
Well, I think we are definitely in a few weeks kind of category. So we are marching towards getting the work done, and when it's done, we're going to schedule with them to present the work complete. So we're going to have a further review next week, and these things are still being discussed, exact dates and times, but again, we're being driven by the completion of the work, nothing else.
Okay, and I understand we have another question from headquarters.
I think Mr. Hale mentioned some new tools that were used to look at the tank. Could you talk about that, please?
Let's see, we had a number of new video tools. They have a number of high-definition television cameras that are in use, an additional set of color cameras that we're putting around the launch pad. The ICE team, and we probably need to get Armando over here to talk about all these new tools, has got a number of thermal sensors that they can zero in on areas of particular interest and measure the surface temperature. They have some computer tools that provide predictions based on the weather conditions, humidity, wind, and so forth. And all of those, they were very happy with the performance of their tools. They did a very detailed inspection. We have a whole new set of criteria documented with thorough engineering background for what is acceptable and not acceptable in the ice frost arena. And so the report that I had from the ICE team was that they were very happy with their tool performance. And we can get you the list of all the all the gadgets that they have. And they have, and of course, a lot of the gadgets are kind of mundane. They use binoculars and those sort of things to look for areas of ice. They had, in particular, put a scribe mark or a magic marker. There's a on the forward LOX bellows to see how the frost formed in there, and measured that very carefully to understand how that was going on. So there's a variety of different techniques and tools that they use today.
Okay, we'll come back to KSC to Mike.
Mike Cabbage with the Orlando Sentinel. Quick question for Wayne. Have you decided, or does it look like that the FRR is going to move beyond the week of TCDT now? And if so, what dates are you looking at?
We are discussing dates and times, and I'm not prepared to talk about those right now.
Okay, Jay.
Jay Barbary with NBC. Well, Mark asked my question, Mike, but Wayne, how are the Canadians doing with the boom, and how's crew training going?
We've been monitoring the crew training workload very carefully. I had a meeting with Eileen Collins and the STS-114 crew last week. That was something that was on the top of my list. Typically, as we get a crew ready for flight, the last month of training is intense, and we need to be very careful that we haven't overloaded them. They had a number of EVA tasks that were defined late in terms of some of the activities. So the EVA training is one of the pacing items. We reviewed her training schedule, her crew's training schedule, and they assured me that they were satisfied that they were not being overworked and could accomplish what they needed to do by the launch date. So I think that's in good shape, but that's something we always have to pay attention to. In terms of the Canadians, they are finishing up their engineering analysis work. You know, they delivered both the booms for both the first and second vehicles, are here and installed on both orbiters. An outstanding set of work, and they are completing the engineering certification. The last part of that is the loads analysis, because we did a number of modal tests, and the results of all of that have been turned back to them to complete their certification work, and they are working toward having that complete in the near term as well. Pardon me.
All right, we'll go to Dan, and we have time for a couple more. Dan Billow from Channel 2 for Wayne Hale. Would you discuss the open items on the tank a little bit more? You've got some concerns about ice. Is that under special circumstances, and are these circumstances ones that before STS-107 you were just living with, or is this something new?
We knew about ice. I mean, we've had a long history of knowing that ice on the forward part of the external tank is important to monitor. Certainly the Columbia accident and the resulting understanding of how vulnerable our thermal protection system is has led us to a new awareness of the levels of ice that we need to be concerned about. In particular, we're concerned about the ice in the LOX feedline bellows. I think I don't know what went out on the television to the public today, but certainly we monitored that very closely. It's going to be an area of special interest. We've set up some operational controls, and we're still continuing to do some testing on what would happen to ice that came out of that area. In a similar fashion, there is ice that forms around the bracket that holds the feed line, the big 17-inch pipe that comes down the side of the external tank. The forward bracket has some ice form in it on occasion. We're very concerned about that, and we are going to control that operationally, if not with other engineering changes. And in addition to that, we're concerned about the possibility of ice and frost forming on the very forward part of the tank, up near the nose cap, on the pressurization lines. Actually, the standoffs, the brackets that hold the pressurization lines, they go up to the very top of the tank, things that are called the ice frost ramp near the bottom of the nose cap. Those are the areas that we're going to have to be very cautious about and watch very closely. So those are the areas where we still have some work going on to understand what would happen if that ice will hold on all the way to MECO, or will it come off at main engine ignition, or exactly what will happen. That is still a bit of work that we have going forward.
Just a little bit more on that. reviews that you have going on that you're talking about, those and others, this whole process that kind of leads up to Stafford-Covey, how do you feel about the status of all of these reviews right now?
Well, the Stafford-Covey folks, I have to say, I feel good that we are going to present them the information that they need. But I would like to rephrase your question. I think all of this leads up to our flight readiness review. I mean, regardless of what Stafford-Covey thinks, we have to satisfy ourselves first that it's good to go fly. We have to complete the certifications. We have to understand the risks that remain. And as a program, Space Shuttle program, leadership, and indeed in the agency, we have to come to the conclusion that we feel that it's safe to fly. And until we come to the flight readiness review, we will not, I mean, that is the purpose of the flight readiness review. So in my mind, it culminates there. Stafford-Covey is supposed to be looking at us with an independent eye to make sure that we haven't got caught up in our own arrogance, I guess, or our own lack of understanding. And I think that is an outstandingly good idea to make sure that people that are not in the middle of this fray get to call, get to make a judgment on whether we've done the work right or not. So they're parallel processes.
Okay, Bill?
Bill Harvey again, just a quick question. Maybe it's for Mike, I'm not sure. I heard some rumblings you guys might, or at least you're thinking about using infrared spots or maybe focus xenons on the tank if you had ice that you could actually melt ice after it formed. Was that accurate or just crazy?
We were asked to look at ground systems that could help mitigate ice from forming in the first place by focusing some sort of energy on the tank. And a lot of those ideas didn't get too far, frankly. And Neil, do you want to tell us why they didn't?
Yeah, and I think Wayne said it right. We're still looking at ice and ways to mitigate ice and decrease risk as we go along. We do have plans in place that we're going through design on a heater for the forward bellows that would preclude ice. We've got some backup solutions as far as sacrificial with insulation in the bellows cavity and a sacrificial type retainer around it. That is possibilities if the program decides that they are in fact necessary. And there have been other ideas such as incandescent lights, the lasers. All of these things take development. You have to be very careful as you go forward that you make sure you understand all the system interactions of all these different options. You don't want to fix one problem and back into another one. So all those are out there. We have looked at them. They're on the table. We keep our options open, and we're continuing to work them.
I really like the laser cannon option, but everybody else told me it was not a good plan. So, you know, the law of unintended consequences operates here. Yes. You can't just run out and throw a Band-Aid on something and call it good. You have to prove that you didn't do something the last 2 years. It's very easy to make things worse if you're not thorough. And so that's why we're trying to be thorough with these kind of ideas.
And we have time for one more if we have it. In the back.
Steve Lee from the Denver Museum of Nature and Science. I was just wondering if the procedures you're following tonight to drain the tank have been altered in any significant way from what you would have done after a scrub in the past.
No, our drain procedures are the same. We went through 2 little special tests when we got down to T-minus 31 seconds and holding. We wanted to verify the temperature at the inlet to the main engines, that temperature excursion behaved as we expected it would, and it did. So we did a couple small tests leading into the cutoff, but after cutoff, our drain sequence is the same.
Okay, thank you, gentlemen. This concludes our press conference. Programming note, please join NASA TV tonight at 8 o'clock Eastern for coverage of the Soyuz launch to the International Space Station. Actual launch time is set for 8:46 Eastern. Thank you and have a great day.